Okay, so if all our panelists are ready to go, we can get started. Are we ready?
Okay.
Um,
I'm gonna go ahead and get started. So thank you everybody for coming out today to ACM AI's research panel. We have some great panelists lined up for you today to talk about their research interests, their research labs, and also how students can get into research at UCLA. So the plan for today is we have some prepared questions for them to answer, and then we'll have a audience Q&A, and lastly, we'll end off with breakout rooms where you guys can talk with the panelists yourselves and ask any questions you have. So I am Kai. I am an ACM AI officer, and I am one of your moderators today. And I'm going to hand it off to Aman to introduce himself.
Hey everyone, I'm Aman. I'm also an AI officer, and I'm also going to be a moderator today. If our panelists are ready, we're going to start with introductions now. Looks like they all are. Looks like we're good to go. So just a request from me and from Kai to drop some clap emojis in the chat to thank our panelists for coming and showing our appreciation as we go over the introductions. Okay, let's begin with Professor Kaiwe Chan. And Professor Kaiwe Chang received his PhD in computer science from the University of Illinois at Urbana-Champaign in 2015. He spent a year with Microsoft Research, a year as an assistant professor at the University of Virginia, and is now an assistant professor at UCLA. He is an expert in natural language processing, and he is also an advocate for fairness and accountability in AI and has won several awards for his research work, such as Yahoo's Key Scientific Challenges Award.
Hey, oh, yeah. So do you want me to talk about my research now, or you want to introduce all panelists first?
Okay, next I'll introduce Meng Du. PhD candidate Meng Du is currently pursuing a PhD in computational cognition. She received her impressive double Bachelor of Science in Computer Science as well as BCN, which is Biopsychology, Cognition, and Neuroscience from the University of Michigan in 2015. In the past few years, she has worked as a research assistant at the University of Michigan and also at Princeton University. And she is a research associate as of now at UCLA. She has led some fine research in computational neuroscience. She is also the recipient of the Grace Hopper Celebration 2020 Scholarship.
And I'll go ahead and introduce our other two panelists. So we have Professor Jang-Suk Ju, who received his PhD in computer science from UCLA in 2015, and he went on to become a research scientist at Facebook, and he is currently an assistant professor in the Department of Communication at UCLA. He is a highly accomplished researcher and has over 20 publications covering topics ranging from characterizing clickbaits on Instagram all the way to protest activity detection and perceived violence estimation from social media. So he's on the lookout for motivated graduate and undergraduate research assistants at UCLA, so stay tuned. And last but not least, we also have Professor Yizhou Sun, who received her PhD in computer science from the University of Illinois at Urbana-Champaign in 2012. And since then, she's been an assistant professor at Northeastern University and is currently an associate professor in the computer science department here at UCLA. Her research interests include large-scale information and social networks, data mining, database systems, and machine learning, among many other areas. And she's distinguished with over 50 publications and many awards and honors, including the Amazon Research Award. So with that, those were our introductions. And I think we're just going to go ahead and dive into our prepared questions for the panelists. So I'm going to hand it off to Amin.
Professor Kaiwe, could you begin by telling us what you do in your lab currently and what your RAs need as of now?
Yeah, sure. Yeah, so thanks for the introduction. Yeah, so my research area is natural language processing. So basically, we are trying to teach the machine to understand and generate human language. And I'm especially interested in designing the model and algorithm for accountable and responsible language processing technology. So our lab has been working on various problems around this angle. So for example, we work on many problems related to fairness in NLP. So the center idea is because the NLP model has been widely used in our daily lives. And despite we have a lot of strong NLP model now, they may discover and is prohibit some social bias in the data. So then we need to super careful when we use this model. Right. So for example, in some of our previous work, we analyzed the bias in the language generation model. And we find that the NLP model may reflect different kind of a general social perception for different demographic groups. So we need to very careful to disable the model to say something bad to certain population. So as NLP system has been widely used in our daily life, so it directly interact with a lot of end users. So then we are super careful when we design such a model. And we're also working on many other problems like robustness in NLP. So we want to ensure a model will not change its prediction if you just change a word to its synonym in a sentence. And also there are other similar problems we are working on that we want to ensure the machine can understand human common sense. Or we also want to multilingual model that can handle multiple language. Yeah, so these are kind of a general research direction that our lab are working on. Yeah, so in general, for all these problems, there are several students work on all these area, and uh, we also have several undergraduate students that are also working on various problems.
All right, that's great. For Meng, could you talk about how, like the type of work that you or other research assistants do in your lab?
Yeah, sure. So I'm in the psychology department actually, and the lab I'm in is called the Computational Social Neuroscience Lab. And what that means is that we study the social functions of the human brain with computational methods. And so our questions, research questions, may be like different from like a research in like a typical computer science lab, in that we ask questions about people. Like, for example, some of our research are about like how do people treat others who are close to them or far away from them differently, or like do friends react to the world more like in more similar ways than like people who are not friends, and like how do people's brain react to like social versus non-social stimuli. So we answer these questions with two types of tools. One is neuroimaging. So we ask our participants in experiments to lie down in an MRI scanner, and like we ask them to do tasks while their brains are being scanned like once per second. So this type we're like not doing this anymore during the pandemic, but we have like a lot of data from our previous experiments. And this type of experiments results in like very large data sets, like a few terabytes per participant. So we have to use our second tool, which is like the computational methods to analyze this data. And this involves a lot of machine learning methods, such as like classification, regression, etc. So I'm currently working on a project where we have brain imaging data of people watching movies. And I'm needing RAs to help with this project. So in this project, we study like we want to know like how the brain respond differently to like movies where like there are different types of social interactions or social relationships happening. And yeah, so I'll need help to label the movies. And if you're interested, you can also learn about how to analyze this data with machine learning methods, like both the movie and the brain imaging data. Yeah.
Thank you so much. That was very interesting. Professor Jangseok, would you like to describe your research?
Yeah, can I share my screen? I have one slide.
Maya?
Yeah, actually, yeah, I can. So, but I want to play animation. Wait, slide show. Yeah, it's my name. So, so mainly, I think there are three areas that my group is working on. So first thing is a human AI intellection. So by the way, so my background is computer vision and machine learning. So I got my PhD at UCLA in Bolter Hall. I used to stay in the 9th floor on the Bolter Hall. And you know, if you're familiar with this structure, then it's kind of not easy to find the 9th floor because you know, you may get stuck in library, stuff like that. But anyway, so my background was computer vision. But nowadays I don't really work on, you know, the traditional computer vision anymore because it's you know, highly saturated for problems like image classification, object detection. But when I say saturated, doesn't mean it's perfect. But the most of solutions are working pretty well. And then in order for us to make additional progress, then you will need a tremendous amount of resource, data, and labor. And those are the things that I don't have and probably can be better handled in maybe industry or some kind of big research centers. But I've been instead focusing more on what you can do with computer vision or AI and what would be the future direction that will be headed. And so one area is human AI interaction and communication. And I'm not gonna talk too much about each detailed project, but just briefly, you know, we're working with people in robotics and mechanical engineering to make robots to understand the meaning of a human communication and gesture and how to collaborate with robots and AI. And also another area is social computing and computational social science or data science. Mainly you can use machine learning or computer vision or any other thing, deep learning, to efficiently analyze a large amount of data that we can easily collect for the research purpose to understand human behavior or, you know, motivations and intent or the future progress in social event or issues such as COVID-19 or election. And the third area, actually, this is related to what Professor Kaiwe Chan is also working on. So ethical issues, how would you trust or how would you explain the behavior of models? Again, my focus has been, you know, computer vision, meaning dealing with the image data. So those are the main areas, although there are kind of other studies, but I think those are kind of main streams of research that we've been working on. And there are actually many undergrad students in many from many programs, including computer science, statistics, and psychology, and also social sciences. So if you are interested in this kind of work, then you're welcome to reach out to me. We can discuss more about the potential topics. So, yeah.
Thank you so much for creating a whole slideshow for us. And also, Professor Sun, could you talk a little bit about what you do in your lab and your RA needs?
Yeah, sure. So, so in our lab, actually, we're doing everything about graphs. Okay, so why graphs? So because in our opinion, lots of things can be represented as graphs. So from one hand, right, so many data can be considered as graph data. For example, social network, Facebook, Twitter, right? So in those data, actually, if we look at the data, so we can consider people as those nodes, but they are not independent with each other. They are connected to each other via links, right? So that's why we can consider some of those data as graph. And not just a social network, but if we consider chemical compounds or protein, right? So they are somehow also like maybe atoms serve as a node and kind of chemical bonds serve as links. Also like a program language, if we do it smartly, we can also turn it into graph. So lots of data can be represented in graph, and we can use graph to capture the dependency relationship between those nodes. Second, some of the knowledge can be represented as graph, for example, knowledge graph, right? So knowledge graph actually try to somehow use those triples to capture the knowledge that collected by human. So if we put all those triples together, actually it's also a gigantic graph. Third, if you think about that, right? So right now, what's the hardest thing? That's deep learning. But if you look at a graph neural network, if you look at the computational graph, okay, the model itself, graph is also helpful to represent the models or like computational units. So that's why we think a graph is quite ubiquitous, quite general, and quite useful. And then what kind of interesting things we are doing on top of this graph, right? So I think the very fundamental thing is like how we can do representation learning, because for graphs, actually, those nodes, right? So if you think about a social network, so essentially those nodes, you can imagine their IDs, right? But then we wanted to use this continuous representation to represent those person, and then we can use that to do some downstream task. For example, can we predict their political polarity, right? So recently we have a project to predict the polarity of each Twitter user according to their tweets. And also, we actually have two projects. One is like according to their tweets, and the other like, let's ignore their tweets just based on the connection, like a follower, mention, reply, this kind of relation. Can we predict the polarity correctly? And turns out that, yes, we can. Okay, that's interesting. So then once we can do the representation learning, which kind of turn the discrete graph structure into this continuous representation, then we can do lots of very interesting things. For example, if we consider graph database setting, right? So then giving a, let's say, a chemical compound database, then give a query, which is represented as graph, right? And how we can use the representation that we have learned, then we can quickly find the most similar chemical compound to the query. So this kind of tool is going to be very useful if you are working on the domain, for example, try to design new drugs, right? So because then you can quickly do the search, try to say that, oh, whether there's some existing drugs in the database that is close to what I want. So then we can accelerate the drug design. And also we are doing something interesting. I think, yeah, Arjun is here. Okay, Arjun actually is working with us. Arjun is an undergrad student, and he's working with us for graph representation learning. Okay, but for that task, actually we're saying that, can we do some sort of pre-training of those pre-training on those graphs? So in other words, without knowing what would be the exact downstream task, it could be node classification, it could be graph classification, right? But can we, but definitely if you want to do that, then you need labels. But can you do this pre-training using self-supervised tasks? So we don't need to collect labels, but we still can utilize the intrinsic graph structure and try to represent them, right? Some other interesting thing I want to mention is recently we also try to, another very interesting projects related to pandemic. So we want to see like whether we can predict the trend of the pandemic. By the way, that's also a course project in CS 145, but we do have like one PhD student working on that project. So then the idea is that right now, most of people, when they try to predict, for example, confirm the case for each state, right? So then we just utilize the data from that state. But we're like actually from inference perspective, right? So each state will get influenced by other states because there's some kind of spatial and temporal inference, right? So for example, if other people travel from other states to this particular state, then definitely we need to consider that. So then we try to kind of integrate the graph and the time series, and then try to have a better prediction. And turns out that, yes, according to the preliminary study, our predictions are already quite impressive. Yeah, so roughly speaking, okay, although I gave some examples, but roughly speaking, I try to say that in our lab, we are focused on graph, and then on the top, that's application. And I've already talked about like social network application, like pandemic prediction application, lots of interest applications. And in the middle, right? So we try to propose all kinds of algorithms that can address different tasks that can be defined on graphs. And on the even bottom level, right? So then what we try to do is like how we can make all those algorithms like scalable to a large scale of data set, right? So that's why we also try to work on like try to design, for example, algorithms that is parallelized algorithm. Okay, so then we can distribute the model or data into different computational resources. So then we can really do the computation. Yeah, so I just want to keep it short. Okay, yeah.
Thank you so much for that, Professor Yesu. Speaking of classes, Professor Jongsuk, what experience is necessary to join your lab, or are there any specific classes that you would recommend for people to take before they apply to your lab?
Not much other than coding skills. Yeah. I mean, it used to be very difficult for students to start doing any kinds of research in computer vision because even pre-processing kind of thing was very difficult. So people used to have a lot of knowledge about that. But nowadays, just there are a bunch of tools that you can easily use, like PyTorch, TensorFlow. So you don't really need to know much other than just using those tools. But I think, I mean, in my lab, the most of projects and then what I'm looking for from undergrad students are not necessarily technical maturity. Instead, it's more about, commitment and more general problem solving skills and communication skills. And those are much more important than any technical skills.
Adding on to that a little bit, Professor Zhu, can you just mention how students can apply to your lab?
Email me with resume or CV, yeah.
All right, great. And also, Professor Sun, could you also talk about how what experience is necessary for students to join your lab, and also like how they can?
So I think it's very similar to Professor Zhu, right? So yeah, so coding definitely is a very important thing. Okay, and also emphasize like communication skills because anyway you need to communicate your ideas with your teammates and so then we can like discuss with each other and try to improve. And also usually I will say that you do have the enough knowledge preparation in the field. Okay, so in other words, for example, if you really like to work with us, okay, then probably we need to have the very basic knowledge in data mining and machine learning, right? And yeah, probably, and the most important thing, you should have passion about research, about doing research. Okay, so I believe once you have passion, then lots of difficulty, then you can overcome. Yeah.
Thanks for that, Professor Yezu. Mang, would you like to go over some of the requirements for your lab and how we could apply to research roles in your lab?
Yeah, sure. So I also agree with the other people that it's more important to have the commitment and the like interest and the communication skills. So for my project, like if you're interested in like jumping to like analyzing the data right away, I would hope you have some experience with like stats and or machine learning. But even if you don't have much of that experience, I would just like ask you to start with something easier and like labeling the data, and that pretty much doesn't really require any skill at all. And yeah, but like the more important thing I feel like is the interest and commitment.
Thank you. And last but not least, Professor Chang, could you talk about what experience students need and how they can join your lab?
Yeah, so similar to others professors say, and for doing machine learning related research, I would suggest you can take the machine learning course or the data mining or yeah, also data science classes Yeah, and you probably don't need to take all of them, but at least take one of them, so then you know some basic idea of machine learning. And you can also ask the professor to allow you to enroll to some more advanced courses like NLP or advanced data mining or deep learning, right? And then that will also expand what you need for doing research. Yeah, and yeah, like I like the other saying that it is actually more important to have a patient and a commitment than because it's easier to learn the knowledge to learn to really have a patient to work on something. So you really want to choose something that you really want to do and then go for it. Yeah, and for joining my lab, there are many ways. Like if you take my course, you can go to the my office hour and you can chat with me, and you can also fill the form in my website, and then I cannot take actually too many students at the same time, but I usually would try my best to take as many students as I can.
Right, that's great. It's great to hear that commitment is the most important thing. So with that, we're going to go ahead and open the floor for audience questions. So go ahead and type in the chat if you have a question, and if you're not comfortable with that, go ahead and direct message me or Amin, and we'll be glad to read it out loud. Also, I think that you can unmute yourself and ask a question too if you prefer that.
Also, if you have any specific questions, please save them for the breakout rooms later. Right now, the panelists will just be answering more general questions. And if you want to unmute yourself, please feel free to raise your hand or type your question in the chat.
All right, so we have our first question, and for our panelists, if anybody wants to answer, just go ahead. We're not going to ask any specific person. So the question is, what skills/traits do you look for in a good applicant to your lab?
Well, I can take the questions. Yeah, and uh, I think like other professors said before, like I think the communication and also some background knowledge is important. So like I suggest, I think if you want to join our lab, I would suggest you to at least take some AI related courses and show that you have some thinking and commitment to those direction. And if you have done some course project, it doesn't need to be a very complicated project, but if you have done anything that related to research, then that would be a big plus, because that kind of showing that you have the patience to work on this area. Yeah.
Okay, we have another question in the chat, and that is, how long is the research going to last in general?
Okay, probably I can take that because I've been working with many undergrad students, and the answer is it depends. Okay, some of them could be quite short, and because like you are lucky, okay, and you're working with usually the first project is like you're working with some PhD students, and you are lucky, okay, you get things done in 3 months, and then you submit the paper and it got accepted. Okay, but in other cases, probably it will take a longer time. And the more interesting thing that sometimes when you start from some project and then somehow you feel that, okay, even I finish this project, then turns out that I come up with more ideas. Okay, so you just keep going and it will never finish. Okay, so yeah, so that's my answer to this question.
Right. The next question we have is, how would the onboarding process look like?
And also, to add on to that, there was another question about knowing TensorFlow and other machine learning tools. Do people need to know that beforehand, or is that something you can learn as you begin with the research?
So for my lab project, it definitely don't have to know any of that beforehand, and like you can learn it after you start your research assistantship.
My suggestion is if you invest for about couple hours, then you'll be able to finish the basic tutorial either using TensorFlow or PyTorch. So I think it's probably a good way to get yourself prepared before starting real research project.
The next question we have is a student was wondering what are good ways to get experience in ML and AI? For instance, what kind of personal projects would be good?
So I mean, so when I meet undergrad students for potential intellection, I usually give them a link to one of the project from my lab with published code and data set and pre-trained model, and then just to play with that a little bit. And then there are a lot of published and public resources like that. And I think just playing around with those resources is probably a good way to learn the practical, application and how to use these tools pretty quickly. Other than and also taking some basic course like on machine learning, AI.
Yeah, I want to also add to that, like there are several websites that you can learn a lot of basic idea, and also there are competition website like Kaggle, right? So then you can trying to solve some AI problems there, and they also have a lot of tutorial and forum that people discussing how to solve the problem. So if you go through one or two these kind of things, then you will learn a lot from trying to make your hand dirty.
I also want to add that, so right now in computer science department, we have provided lots of very good ML and AI related upper division courses. And I strongly recommend you to consider that to kind of learn the knowledge more systematically.
Question we have is, would it be necessary to invest in a decent graphic card for ML research since everything is remote right now?
So I would say, Google provides this collab, so you can running decent size of a model for free on the collab, and there are also many resources that you can use for free. So I won't say you want to spend a few $1,000s to buy a graphic card just for try out some research idea. Yeah.
Yeah, personally, I tried a Google Colab. I just fear it's already very good. Okay, should be enough for just to play around.
Okay, thank you. There's another question in the chat about what kind of responsibilities and commitments would you expect from undergraduate researchers, like terms of hours of work or types of duties?
Okay.
So, sorry, go ahead. Yeah.
Go ahead, please. Go, please.
So I think it depends. So, but like typically, if you want to get involved in research in my lab, I would expect probably spending about 20 hours a week. But I mean, if you're busy with coursework and the midterm and final, of course, that can be flexible. But I think the most important thing is if you start a research project, and then if you take a role as leading author for a paper project, then I would want you to finish it or and needs help somebody else to take over when you are leaving after graduation, so that the project can be not wasted. So that's the most important thing, because no matter how hard you work while you are working here, if it's not published, then nobody cares. So you have to finish it, and that's important. I think responsibility wise. Yeah.
Yeah, so I just want to comment that almost every undergraduate student I have worked with are so committed. Okay, so I know that you are very busy and taking so many courses, but still, yeah, just based on the, for example, weekly discussions, right? So yeah, I understand that they have contributed a lot. Okay.
For me, I usually don't put pressure on undergraduate students, because I know doing research is kind of an add-on to their workload, right? So it's not like they are committed to do research here, but it's more like the most time you spend, the more effort you spend on those projects, then you get more from those projects. So including more knowledge, including you may be able to enhance your resume, right? So it's really the question that how much the time you want to spend on these, and how much patience you have to do research.
Yeah, my view is also more similar to Professor Chang, and I also feel like no matter like how much time you devote into your project, it's kind of important that you kind of finish what you're committed to do, and like because it's a little frustrating for me if like someone promised me to do something and they just can disappear, and yeah, and can't find them. That's very frustrating.
Thank you for answering, everybody. The next question we have is, from what year, i.e. freshman, sophomore, junior, do you recommend starting research?
Yeah, so I would say it depends. Yeah, I would say you want to start the research when you feel you are ready. And I say that because if you don't have enough knowledge and then jump into some research problem, research problem is not like homework that you really know there is an answer there. Usually you will need to kind of go around in the jungle to find the right answer. So it's not that obvious. Yeah, so I see sometimes if you are not ready enough and jump into the jungle and you got lost, right? And then you start to feel frustrated, start to feel stressful, then that's not necessary. So that's why I think when you start looking for the lab is not that important, but when you feel ready and you have enough knowledge that you can start doing some research work, then I think that's probably the right way to ask yourself when you should join the lab.
Yeah, so in my case, yeah, I think many of them kind of start working with us when they are junior. I think that might because when you are junior, then you have chance to know those upper division courses, and then somehow you develop the idea of what research is and how we can do research, and then you started to build this interest and the knowledge preparation. So I guess that's the reason. But I agree with Professor Chang, right? It really depends. If you, I know like there are some freshman students, and they're saying that I have already done something in high school, right? So do you want to work with me? I said yes, and then a couple of days later, he said that actually I think I had a better idea to work with. Okay, but now you, okay, it's a different professor. Yeah.
All right. Does anybody have any more questions before we start breakout rooms where you guys can ask questions to whichever panelists you'd like?
Remember to fill out the feedback form if you haven't.
Yeah, do not forget to fill out the feedback form. Yeah, so also for breakout rooms, we have some sample questions that you can ask in the brochure on the panelist info link we sent out. So that is to get the ball rolling. But if nobody has any more questions, Maya, if you could get the breakout room